A higher order function is nothing more than a function using a function for an input or output. That's functions as arguments or return values. If we back up for a second though, we should start the discussion by talking about first-class functions. Think about the function head here. It takes an array, it checks if the length is greater than 0, and if it is, it'll return the first element, otherwise it returns a null. We don't really question our ability that we take array as an argument. We don't also question our ability to return a type like a number from a function as well, such as with square. And finally, we don't really even question the idea of assigning an object to a variable such as config. We are using these types in a very natural manner in our programming, but the truth is that we can do the same thing with functions themselves. So in this function random here, we take a function as an argument called callback and then call it with some random number. We also can even return a function from a function. And we'll go into a little bit more detail with the function add here in a bit. But what you need to know now is that there's no problem returning functions from inside of functions. And finally, you can even assign functions to variables in the case of square. It just takes a number and then multiplies it by itself. As we start to think about this, first-class function support is required for higher order functions. But let's step back for just 1 second. I want us to think about what it means for something to be a first-order function. We'll start by writing a function add, and we're then going to turn it into a higher order function. But right now, all add does is take a left and right parameter, add them together, and return the result. If we were to call it with 1 and 2, and then we were to, let's say, log this to the standard output or console, we would get 3 just as we expect. What should be noticed here is that the function add, there's no functions as arguments and there's no functions being returned. It's just numbers. This can be thought of as a first order function. There's also an alternative syntax to writing this that you should be familiar with, and it's the fat arrow syntax. It looks a little bit like this. Just keep that in mind as we go forward. So now that we've established a first order function, let's look at a higher order function. We'll expand on add a little bit. Our add function now takes a left parameter, then returns another function. That function takes a right parameter. It does the same body of work, which is add the two left and rights together though. So how do we use this? Well, think about it this way. If we call add with 1, it's going to return us a function that's still waiting on right. If we were to then, let's say, call add 1 with 1 itself, and maybe we'll do another one where we'll do 5, it's at this point that the inner scope of left plus right takes place. So if we were then logging result 1 and result 2, we'll get 2 and 6 sort of as we expect here. So it's a way of sort of deferring that execution a little bit. Now, I want to quickly go over some alternative syntax. This comes up a lot in JavaScript. We can use the fat arrow syntax to write these higher order functions, where you kind of have a function being returned from a function. There's even one that's a little bit more terse than this, and is very popular in kind of functional programming styles. You simply have left, right, and then left plus right. It might take a minute to see that these are all the same, but they in fact are. Let's take a look at higher order functions as inputs. A very common function that takes a function is the function map. It takes some transformation and works on some collection. We basically set up a result output. In this case, we'll just have it be an array. And what we do is, for each item in our collection, we just take that item and transform it. And the transform is up to the client to decide what that is, or what they wanted to pass in. So how would we use this? Well, we could, for example, have a function called add1 that simply adds 1 to some given number. We'll store that away to the side for a second. And then to call map, we can just pass it add1 and then give it some collection. In this case, just 1, 2, and 3. If we were to log the result variable, we would simply get 2, 3, and 4. But this is a good example of a function map where you're letting the client pass the transformation in. What will happen a lot of times in programming is that in two separate parts of an application, people will have some logic that's iterating over some collection and doing some transformation to it. And I want you to pay close attention to what just happened in there. Take a look at item plus 1 and item divided by 2, because there's an important point to be made here. These two functions, add1 and divide by 2, are identical except for this transformation, and this is what you should look for when you want to find these refactoring opportunities. What it means is, if you look at map here, and then look at that transformation, what map does is it lets the client pass in that transformational point. So now, instead of having to take care of add1 and divide by 2, you have one function map, and you'll find these opportunities throughout your code base. I want to look at one last thing here, and that's function composition. And the reason why is we looked at functions as inputs and functions as outputs, but the function compose is a good example of a function that does both. It takes, n number of functions as inputs and then reduces over them, basically passing the result of each successive call to the next. So if we were using this, we could say add1 divide by 2 is equal to, and then give it a couple of functions that we'd like to compose together. And because compose returns a function, add1 divide by 2 is a function itself. So take a look at that. That's functions going in and functions going out. And what it means is if we were to, let's say, log the result of passing it 9, we'd get 5. This is an incredibly powerful concept and sort of takes the idea of higher order functions to its logical conclusion, which is functions in and functions out. Please remember to subscribe. We give out free merch every month, and we'll see you at Polyseer.io.